All right. So, Guyan Creek Middle School students and their favorite ice cream. Okay. Journey, please put the phone away. Thank you. All right. What is the probability that a person is selected at random is an eighth grade student? So, if they're selected at random, what is going to be my denominator? What is it? 900. This total, unless it is conditional, your answer is always going to be 900. So we could put that for letter B. Letter C is conditional because of that vertical line. So that's not 900. And letter E also ends in 900. Okay? So it's important to recognize and realize that when you have this two-way table. Let's put the phone away. Put the backpack down. Do you have your review out? Please take it out. Journey, can you please get that? All right, so the probability of selecting in eighth grade. Look at all. Hey, come on. I don't need you guys fighting. I asked you, can you please get it? So that is 250 out of 900. Okay. Letter B. Letter B says calculate. Christian. Christian. Come on. Keep your head up. Journey. Phone needs to be away. Calculate the probability of swirl or. This looks like a U. That is an or statement, okay? The U, I want you to think of union or unite. Because when you want to get in a union, you want as many people as possible to join. So that means I want all squirrels plus all eighth grade. And then I'm going to subtract from that total all eighth graders who like swirl ice cream. Okay, that's what an or statement is. All the swirls, all the eighth graders, minus those that are part of both. So all swirl, let's do this in blue, is going to be 533. Okay, that is at the end. That's that total. All of my eighth graders is 250. That falls at the end of that column. So plus 250. And then there's one group of people that we have counted twice. If you look right here, we have counted 168 people twice because they fell at that intersection. Woodery. Hey, up here, please. They have fallen in there twice, so I have to subtract 168. So when you have your calculators, you will add 533 plus 250. You will get a total of 783. And when you subtract, you are going to get 615 as your numerator. And that goes over the 900. Questions on that?
What is that?
What is? I don't know what you're talking about. This? Yeah, that's a 3. 783. And then take 783 minus 168. Any questions on B? Reagan, put the phone away. Letter C, this is a conditional statement. A conditional because it's not about the whole sample, not about the whole sample. It is about, in this case, what comes behind that conditional statement, which is swirl. So you need to find all swirls, all people who like swirls. And that bottom is 533. Dwayne, let's write this down, please. So whatever falls behind that vertical line, that is the total for whatever that category is. Of those who liked swirls, we want the sixth graders. So follow along that swirl line, find your sixth graders, and that number is 212. So 212 sixth graders out of all who like swirl ice cream. Questions on that? That's letter C of number 2. That's conditional. Okay? Got a question? Or you want to watch the next one, which is conditional too? All right, so what's the probability that an 8th grader prefers strawberry? This too is conditional because of that vertical line. What falls behind that is 8th graders. That means I want all 8th graders. How many 8th grade total do I have? 250. That is your denominator then, because it is conditional. It's not about the whole sample. It's only about 8th graders. And of that 250 8th graders, how many liked strawberry? So you follow that 8th grade line. 82 out of the 250 preferred strawberry. Okay? And the last one, there is no conditional for this. So this is about the entire sample, which is out of 900. I need a 7th grader that prefers swirl ice cream. So that is 7th grade and swirl ice cream. If it is and, it happens to happen at the same time. Can you wait just a minute? Let me finish this one. What was it again? 7th grade and swirl. So here's swirl. Here's 7th grade. Who are my 7th grade swirl people? It is where they intersect at the same time. So that is 153 out of the 900. Yes, Woodery, question? Probability. Probability. I know, you get so used to it that you kind of forget what it means. So remember, when it's probability, you have to have a numerator, you have to have a denominator. Any question about how to get any of those values? I guarantee there's going to be a problem like this on the test tomorrow. Okay. Should we do 1 right away to get that done? Or somebody said 11. Huh?
Yes.
11 or 1?
9.
9. Somebody else said 11 though, I thought.
We already did 11.
11, 12, and 9?
Yeah,
okay.
We already did 11, and we already did 12.
All right. Let's do 9. We can do 9 very quickly. Juan is choosing an outfit for school. He has 14 shirts, 15 pairs of pants, and 12 belts. This is the fundamental counting principle. It's where you take the total number that you have of choices for each type and you multiply. You just multiply. So we have 14 shirts, 15 pairs of pants, 12 belts. That means you take the total number you have of each type and you multiply those together. So this is 14 times 15, if your pen works, times 12. 2520? Thank you. And that is the total number of outfits. It is not a probability. You just multiply. Okay, I still can't remember. 11, you asked about 11. A random sample is conducted. Based on the sample, it is estimated the proportion of the population has a certain characteristic of 0.37. We already did this one, but someone was not with us, so they asked about it. So I made up the characteristic. Maybe it was the probability that they had a pet fish. I would say about a third of people maybe have pet fish. I don't know. So that is 0.37. We have a margin of error of 0.09, guys. Shh. So you need to add and subtract that margin of error, because the margin of error can make it a little bit higher and make the range a little bit lower. Okay? So I added 0.09 to 0.37 and got 0.46. I subtracted 0.09 from 0.37. Remember, when you're adding and subtracting, you have to line up your decimals, or you just add them and subtract in the calculator. And that gave me a low amount of 0.28 and a high amount of 0.46. Because our sample, yes, we know what the probability is for the sample, but for the population, which we cannot count all of, we are going to have some error. So that's why we expand it and make that range, acceptable range, bigger. Then it says, which is of the following is appropriate. And it says it is plausible. Plausible just means possible. Is it possible that the proportion is less than 0.28 on the smaller side? No, that doesn't fall in the range, so we cross that out. Is it possible it's exactly 0.37? We said, well, maybe, but we have to pick the best answer. Is it possible that it's greater than 0.46? That would be over here. No, that's not, so we cross that out. Is it possible the proportion is between 0.28 and 0.46? And that is the best answer. So the maybe got crossed out. Any questions about that? All right. So that takes care of. Yes. Do you have a particular question?
It's like later, but like I want to ask you, how do I do the thing on the calculator?
Okay. All right. Number 10. Excuse me. Your phone has a 6-digit code. Anytime you are talking about codes, is order important for a code? Yeah. And so that would be what type of a thing? A permutation or a combination? Permutation, pom-poms, order matters. Permutation, order matters. Okay? So this is a permutation. We have a 6-digit code with numbers 0 through 9. 0 through 9. It is a permutation. Justify my answer because order matters. Okay. How many possible? Now, I don't like that we wrote combinations. It's not a combination. It's really, we want to know how many possible codes. How many possible codes are there if the digits are allowed to repeat? Okay. You don't have to do anything in the calculator. How many numbers do we have to put in? There are 6. It is a 6-digit code. So I would tell you, make 6 blank marks. Okay? When you make those blank marks, that tells you how many options you have. Now, this says the digits are allowed to repeat. So we could have 111, 111. All right? But we have the numbers 0 through 9 to choose from. How many different numbers is that? It is 10. Some of you might have been thinking 9. It's the numbers 1 through 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus 0. So 0 plus the 9 gives you 10 total. So how many different numbers could I put in that first position? 10. In the first position, I could put a 0, I could put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not 10, sorry, 9. If I can repeat those numbers, how many different numbers could I put in the second position? 10. And the third? 10. So it is 10 all the way down. This is not the permutation part here. This is just saying, if we are allowed to have repeated numbers, how many total could I have? This, when you use 10 as a factor 6 times, is the same as 10 to the 6th power. And as a shortcut, 10 to the 6th power is a 1 with 6 zeros. That only works with the powers of 10. Okay? It has 6 zeros. So this answer is 1 million. The answer there is 1 million. Now, again, they use the word combinations. I would use codes here because it is not a combination in the probability sense, and I think that gets confusing. So how many possible codes are there if the digits cannot repeat? That you still have 6 spaces. And again, I am a big proponent, or say, please mark the spaces, because then you can think about it logically. So how many different numbers could I put in the first position? 10. But now they cannot repeat. So whatever number you've picked for the first one, you can't use again. How many numbers could you use for the second position? 9. Once you've picked those two, then it's 8, 7 times 6 times 5. Miss Thede, why didn't we go all the way down to number 1? Because it is only a 6-digit code. Okay? So you multiply 10 times 9 times 8 times 7 times 6 times 5. 100 what? I believe that is correct. Now, this is the permutation part, because in a permutation, you do not replace things. It stays out. So when it talked about, is this a permutation? This is a permutation of 10 different numbers taken 6 at a time. So that would be the 6 spaces and 10. And if you do that on your calculator, you would get 151,200. You would get the same number. Questions on that? All right. What other ones would you like to see or that we haven't done? 13.
All of them.
We've done most of them.
There's 2 13.
There's 2 13s? Do you want the first 13 or the second 13? Or both?
Both.
All right. I'll start with the second 13. A spinner is divided into 5 equal sectors. This is on the very last page. 5 equal sectors. A sector is like a section. It's a spinner, okay? The spinner is spun 100 times. So this is my experiment that I'm going to do this over 100 times. The table shows the number of times the spinner lands on each color. So this is the data for my experimental probability. So first of all, it says calculate the theoretical probability of landing on red. Theoretically, if you have 5 different sectors or sections, what's the probability that we land on red? 1 out of 5. There is 1 red section out of the 5 total sections. Okay, that's what it should be in theory, in your head. But we spun that spinner 100 times. And these are the results that we got from our experiment. So this says calculate the experimental probability of landing on yellow. So find yellow. How many yellows did I get? 21 out of, how many times did we do this experiment? 100. So that is your experimental probability. So if you add all these numbers up, yes, you will get 100. Now, this next question is the one that has been really getting people. Using what you know about the law of large numbers, how many times would you predict the spinner is going to land on green if you would spin it 500 times? Whatever that number is, you are going to multiply by the number of times they want you to either roll the die, spin the spinner, whatever. You want to pick the experimental probability. That has the larger numbers anyway. So think of law of large numbers. I'm going to use the probability with the larger numbers. And as a probability, 21 out of 100 is 0.21. So if you take 0.21 times 500, you are going to get 105. So that is the number of times we would expect green. Wait, I messed up again. They changed the color. So I was doing it for yellow. Did anybody notice that? This says green. My bad. Green. Green is 18 out of 100. So that's 0.18. So you have to check, are they using the same color or are they making it different? So back that up. Very sorry. 0.18 times 500 is going to be 90. Thank you. Okay. All right, guys. I need to give you the exit ticket. So put this away. I will include all work, all answers on today's Canvas. Okay. Today's Canvas dates.